So let's take a look at the other rules for inverse trig functions. So what we proved in the last video is that derivative of inverse sine is 1 over the square root of 1 minus x squared. And what we're going to see are similar results here for these different inverse trig functions, where when we took derivative of regular trig functions, it kind of produced another trig function. Here we're getting expressions in terms of x is what's coming through. Now, like I said in the last video, we could find and derive each of these using those properties of inverse functions with derivatives. However, we did inverse sine. That's good enough for me. You can try out the others, but at this point, we're just going to give you the rules and then we'll use them. So negative 1 over root 1 minus x squared for inverse cosine. For inverse tangent, 1 over 1 plus x squared. And kind of similarly to before, the good ones to have memorized will be inverse sine, cosine, tangent. The other ones we'll just use to kind of look up, but try to get sine, cosine, tangent down. So inverse cosine is going to be negative 1 over absolute value of x times the square root of x squared minus 1. Inverse secant is going to be positive 1 over absolute value of x square root x squared minus 1. And then inverse cotangent is going to be a negative 1 over 1 plus x squared. Okay, so from there, let's go ahead and try out some examples. So we're going to take the derivative of inverse tangent of x squared. And what we can do is now we can just use the rules as they're given to us. We don't have to derive it. So this is going to be chain rule where we have outside function of inverse tangent. So if we're taking the derivative, inverse tangent tells me to take 1 over 1 plus, and then we're going to keep the inside function the same. So keeping the inside function x squared, and then whatever our input is, we square that because of our inverse tangent. So the derivative of inverse tangent is 1 over 1 plus x squared. So that first x squared is coming from the inside there, and then we have another square. And then I need to multiply by the derivative of x squared, which is 2x. And then we'll just do a little simplifying. So we have 2x up in the numerator over 1 plus x squared squared is x to the 4th. And that's all we can do. I left way too much space to do that problem. Quick little 2 steps there. Okay, a little more complicated here. We are going to have multiplication, so with that we're going to use the product rule. So, taking the derivative, now let's go ahead and write this out. I'll have derivative of x squared times inverse sine of x plus x squared times derivative of inverse sine of x. Okay, so derivative of x squared is 2x. We have inverse sine of x plus x squared times the derivative of inverse sine of x, which is 1 over the square root of 1 minus x squared. And then just, not much to simplify here. That'll still be 2x inverse sine x plus x squared over root 1 minus x squared. We could take steps to combine that into a single expression by making a common denominator, but that's really not going to do much for us, so let's leave it just like that.